All right, so welcome back to part 2 of the project example video. So if you haven't watched part 1, please go watch that because I explain about walk you through the rubric of the project. So like the directions that you need to do to make your project successful. I also go over how you can do your introductory by giving you guys an example to look at. I also teach you guys how to find the measure of central tendency in that one. So in this video, we're going to continue from that other one by starting off with finding the measures of dispersion. So that's asking ourselves, how is the data spread with the data that you are given? So one way we can calculate the spread of the data is calculating the standard deviation, because standard deviation is the average distance from each data point from the mean. So I'm going to calculate this, but first I need to know what the mean is. So in the previous video, I calculated the mean to be 79.96%. Now, actually, I'm not going to write the percent here. So 79.6, and I rounded to 2 decimal places. So when you do your project, please at least put like 2 decimal places for as much accuracy as possible. So I would ask for 2. And the number of terms here I have are 20. I have 20 test scores here. So to calculate standard deviation, you might remember this from the, I believe I did this calculating standard deviation in Journal 69. So please watch that video if you don't know how to calculate standard deviation. So the first step to calculating standard deviation is finding the variance. So you have to calculate the variance first. To calculate the variance, it's the formula, I'll write it here to the side. So variance is that sigma squared summation of x minus the x with the bar on top, which means the mean, over the number of terms. So I'll kind of put this to the side here. So to calculate your variance, I need to do this for 20 terms. So this parentheses here, I'm going to need to have 20 parentheses. And it's going to be a while that I'm going to have to write. But like the first term here, by the way, I also put these in order by just copying and pasting it from when I put them in order to find the median. You don't have to have them in order to find the standard deviation, but it's kind of nice to see them in order. So the first value here is 31, so I'm going to grab that. So 31 minus my mean, which is 79.96. If you have decimal places, no matter what, please do not round when you're trying to find the standard deviation. And what I mean by round, don't round to the whole number. I know it's so much easier to work with whole numbers, but because we're finding the standard deviation, I don't want you guys to have a bunch of rounding error. Because we're going to be squaring it and then taking the square root of it, and it's going to cause a lot of error if you're rounding to the whole number. So let's try to avoid rounding to the whole number for the mean and just use it as a decimal form. I know it's annoying, but it's going to make the data a little bit more accurate. So I'm now going to do it for the second term. So that's going to be 39 minus the mean again, which is 79.96. So the mean's not going to be changing. And the third term is going to be 43 minus 79.96. Now this is going to take me a while because I'm going to have to do it for all 20 terms. So I'm going to pause the video, and then when I get done, I'll start the video again. Just because this is going to be kind of boring, you watching me write down all the. Alright, so I have written all 20 terms here in their parentheses. And so now this is all divided by the number of terms I have. So this is all divided by, I'll just put like one big line here, one long line here. It's going to be divided by 20. Okay, now obviously mine, this is the only way I could fit it all, but this is totally fine if you want to write it this way, especially for those of you who are doing Google Slides. You might have to do it this way because it only can fit so much on the screen. I mean, if you're doing this on a poster board, you could probably write one very long sentence or very long line of these parentheses all over 20. But as long as I'm seeing the work here, I'm not going to be too picky on how you show this. Now, the next thing I'm going to have to do is simplify all of this part. So I'm going to have to subtract and then square it. Now, I'm not going to show the subtraction and then squaring it. I'm just going to go ahead and get that number. And then, so I'm going to subtract the number and then square it and just have that number. So, let me shrink this down just a bit. Let's see here. There we go. Let's pop this to the side here. So what I'm going to do next is take that first term here. So 31. 31 minus 79.96 gives me negative 48.96. If I square that, I get 2,397.08. I'm just going to round to 2 decimal places. And then I would do the next one. So now I would do 39 minus 79.96, and then I would square it. So this obviously is going to take me a while. So I am going to, again, pause the video and figure out all my calculations, and then come back to you guys. So this here, after I subtracted and squared it, it was 1,677.72. Okay. Okay, so I've subtracted all the stuff in the parentheses and then I've squared them. And so here are my results. Now I'm going to write that line underneath to say I'm dividing this by 20. So the next step I'm going to do is take all of these numbers here and add them together, and then I'll divide that by 20. So again, I'm going to need to maybe move this just a little, shrink this down just a bit so we have some room here. There we go. So I'm going to pause the video and then calculate this by adding all the numbers up. All right, so when I added up all my numbers here, I got, let's see, 9,726.92 divided by 20. If I divide that by 20, because I have 20 terms, I get 486. I'm going to round to 2 decimal places, so 335. Okay, so I just realized that I messed up on the number of terms. So the number of terms in here is not 20, it's 23. I forgot that it was 23 that I had collected. I was wondering why it looked like I did more than 20 terms. So let me change all of that there, my bad. So let's change all that to 23. Change this one here, oops. Here to 23. And now we're going to divide this number here by 23. Hope I keep grabbing the highlighter. So if I divide this by 23, this number is going to change. So I'm going to erase this part and recalculate this. So just all I got to do is divide by 23. So 9726.92 divided by 23 gives me 162.04. And this here is my variance. However, the variance is not really that significant to me. I have to find the standard deviation. So step 2, find standard deviation. So to do that, that's taking your square root of the variance. So the variance here is 162.04. If I take the square root of this number, I get about 12.73 as my standard deviation. Okay, so now I'm going to use this number here and go ahead and interpret the standard deviation in the next slide. Okay, so next we're going to interpret the standard deviation. So there's two things that we'll need to grab. It's the mean and the standard deviation. So the mean here, because we're doing interpretation this time around, you can go ahead and round both the mean and the standard deviation based off their decimal value. So the mean here is approximately, I would say, 80%. So on average, 80% is the average test scores. Whereas this one here, it is a 0.7, so you do need to round up. This is going to be 13%. So if I were to create a normal curve, let's figure out where our probabilities lie at. So this middle part here is going to represent 80. And then to the side here, I'm going to go out to 1 standard deviation. So for 1 standard deviation, how much do you add to the mean? Well, the standard deviation here is 13. So if I add 13 to the mean, which is 80, 80 plus 13 gives you 93. Whereas the other end of it, 80 subtracted by 93 gives you 67. No, not 77, 67, my bad. So that means that in 1 standard deviation, 68% of the data lie between here. So we can already say about 68% of the test scores lie between let's see if I can correct my spelling, 67 to 90%. Okay, so if I want to find 2 standard deviations, I would just go out another one. And so if I add 13 to 93, 13 plus 93 gives you 106. Whereas if I subtract 30 from this side here, this would give us 40. Let me just grab a calculator just in case. So 67 minus 13 is 54. Okay, so that is going to be for 2 standard deviation. So 2 standard deviation is covering the 95% of the data. And then last but not least, we're going to calculate the 3rd standard deviation, but I'll just write here, this one's part 1, part 2, about 95% of the students, oh sorry, not students, test scores lie between 54 to 106. So majority of my data is going to be found here in this percentage at 1 standard deviation. If you have 2 standard deviation, this actually counted for all of my upper tier range. However, 54 is not the lowest grade that someone made on my test. You might have noticed those 30s on the test that I had a moment ago in my data. So I need to cover that ground. So in order to cover that ground, I might need to go into the third standard deviation. So the third standard deviation would be 68 plus another 13 times 3, or you could just take 106 and add it with 13 to get 119. So the other side here, if I were to subtract 13 from 54, that would give me a, let me erase that right there. So that would give me 41. And so if I want to know the range for the 99%, so 3 standard deviation would give me 99% of the data would be covered here. So I can say about 99% of the test scores lie between 41 and 119. Also, I think I made a little typo here. This should have been lie, not like. All right, so that's it for the interpretation. I really just want to see these 3 components here. You don't even have to draw up this graph. It does help a little bit to visualize, but mainly this part. And also mean and standard deviation you can round, so it just makes it a little bit easier when you're talking about it using words. Okay, so now we are on displaying data, and so I'm going to start by showing you how I would do it using a frequency distribution table. So up here I have my numbers listed again. And guys, I've been listing these numbers every time on these slides just because I need to be able to see them when I'm doing the project. But obviously, if you only listed them once, that's enough. I just can't see them when I don't have them on the slides. So that's why I keep having to rewrite them so that you guys can see them and I can see them. All right, so first things first, if you want to make a frequency table, you gotta know what the class width size is. So it's this here. To figure that out, one, you have to decide on what is going to be your number of classes you're going to choose from, or the number of intervals you decide. Now, for me, let's say that I haven't made this frequency table yet, and I don't really know what I'm going to make my number of classes. So the first thing I'm going to start by is just figuring out what is the difference of the biggest number with the lowest numbers, because the class interval formula, if you've already forgotten, so if you want to know the class interval width, it is taking the biggest number and subtracting by the smallest number over the number of classes. So if I take the biggest number here, which is 101, subtracted with the smallest number here, which is 31, that's going to give me 70, right? So in that case, since it's 70, I might want to make the number of intervals for mine maybe 7, because it would like divide out really nicely too. So the number of classes that I'm going to choose is 7, because if I divide by 7, I get 10. Now, I could have also chose 10. 10 divides into 70 really well too. To be honest, I could have done both. Yeah, I could have done 10 as well. So I just chose 7 because it was the first number that popped in my head. So I'm going to see how it goes, and so that means I have to have 7 rows here to do it for a class with or to do it for a number of classes of 7 and a class width of 10. So if you remember this in, I believe, Journal 69, this is how I start it. I take the smallest number that I have on the list, which is 31, and I have to start with 31. And then if I want to know what the next number is, I always add the width size to that number. So 31 plus 10 is 41. 51, keep adding 10, 71, 81, and 91. From there, if I want to figure out the number on the right side, so I've only figured out the left side of the interval, the right side is basically the number before the next number. So if this is 41, the number behind it is 40. And so this one would be 50, 60, 70, 80, 90, 100. All right, so one thing that you guys might have noticed is that I end at 100, but my highest number here is 101. So I need to cover that number. So if you are in this situation and you notice that you didn't cover all the numbers, no worries. All that means is that you didn't find the right class size. So what you could do is you could change your class size, or you could just add another row to your frequency table and continue on the pattern. And that's exactly what I'm going to do, because trying to recalculate that is going to take more work than really needed. So what I'm going to do here is just draw another row here and continue it on like if I had a 8th row. So this would be 101 to 110. And there we have it. That covers all my numbers. So like I said, if you didn't cover all your numbers when you created the class size interval, no worries. Just add another row, as many as you need. So now I'm going to try to figure out my tallies. So in this case, numbers from 31 to 40, that's going to be 31, 39, and that's it, 2 tallies. And I'm going to count that as my frequency as just 2. From 41 to 50, that is going to be, let's see, just 1. So I'm going to go fill out the 2 columns here. So I'm going to pause the video so I can fill that out. Okay, so I filled out the 2 columns here. Now I'm going to fill out the relative frequency. And so if you want to know the relative frequency, all you got to do is take the number of terms you have. So the number of terms I have here, I believe is, let's see, if I add all these up here, that would give me 23 terms. So I have 23 terms here. In order to figure out the frequency, relative frequency, you take the frequency and divide it by the number of terms. So that's going to be, for the first one, 2 divided by 23. And I should get a decimal number for that. Which is about 0.09 if I round to 2 decimal places. I'm going to do it for the next one. 1 divided by 23. And I'm just rounding to 2 decimal places. 1 divided by 23 is still 0.04. 2 divided by 23 is going to give you 0.09. 4 divided by 23 would be 0.17. 3 divided by 23 is going to give me 0.13. 7 divided by 23 is 0.30. And last but not least, 3 divided by 23 is also 0.13. Okay, now we're going to check if this does give us the cumulative. So I'm going to go ahead and do that here. Remember, it's always taking the first number here and putting it on here. So that if you want the first row, this is 0.9. If you want the second row here, the cumulative frequency, you're going to take both of the two. So if this is the second row, you're going to take two of the rows and add them. So if you add those two, you get 0.13. And if you are on the third row, you're going to add 3 of the rows now to get 0.17. And then you would add 4 rows, so that's going to be 0.09 plus 0.17, which is 0.26. If you add 17 to that, you get 0.43. If you add 13 to that, that's going to be 0. I'm just going to be using the calculator just to be safe. Which is 56. If you add 30 to that, that's 86. And if you add 13 to that, that is 99. Okay, so notice how like this cumulative here is 0.99. It's really darn close to 1, but it's not quite there. And that's mainly due to rounding error. So because I was rounding to the second place here, there could be a slight chance that this sum here might be a little bit off. Now, let me just remind you guys, like if you're just a little bit off, it's not a big deal, just keep going. But if you are a lot off, like you got like 1 point, I don't know, I would say even 1.5 is off by quite a bit. But this here, I'm only like a 100th point away from 1, so I'm pretty close to 1. So if it's just off by a tiny, tiny bit, not a big deal. But if it's off by a lot, then you might need to go back and rework the problem out. So from here, next thing I'm gonna do is probably graph a histogram bar in the next slide. All right, so we're gonna make a histogram next. So that's basically a bar graph with no gaps. I did put I took a screenshot of my frequency table here so that way we can see the data points because we're going to be graphing the frequency. So I'm going to draw my histogram here. And so I have 7 intervals here. So I'm going to need 7 bar graphs. So that's 1, 2, 3, 4, 5, 6, 7. So maybe I don't need that much. So let me erase some of this. So from here, I also noticed that this histogram here, the highest number is 7. The frequency highest number is 7, where the lowest number is 1. So maybe I will put some dash mark here and go all the way up to maybe 8. I think that's good. Okay, so when I'm making my histogram bar, make sure you label your intervals. So this is from 31 to 40, and 2 showed up for the frequency there, so I'm going to move the bar graph up to 2. And then just color that in. So that is for 31 to 40. And then this one here would be 41 to 50. Do this one in pink, and it is only a frequency of 1. Okay, so I'm now going to do this for the rest of them, and so I'm going to pause the video so I can complete the rest of the graph. Alright, so I have graphed all the frequency here, and I've also labeled the histogram. So these were about the test scores, and I also put the unit here, so it's percent, and the number of students based off of each test score. So that's pretty much it, all you need to do for the histogram. Okay, so now we are going to graph the pie chart. So to graph the pie chart here, I'm going to be graphing the relative frequency. and then labeling each portion by the correct interval. So first I'm going to make a circle, and I believe maybe it's this button here that will allow me to make a circle. Aha, there we go. I made a beautiful circle on one try. Just kidding, I just have a program for that. So making my dash line here, I'm going to cut this into 1/4. Or maybe in this case, when I'm looking at the numbers here, it might not be good to, well, would it be good to use 1/4? I'll just use 1/4 for now, and if I need to change it, I will. So I'm going to cut it into 4ths. And so looking at like the first one here, this one's about 0.09. Okay, so that's about like a tenth, like 1/10. So in this case, if this is like 25%, right? If I were to cut this into like 5 pieces to make 5%, need about like this much for 10%. Doing a little guesstimation here. So I'm going to designate this spot right here to be 31 to 40, and I am going to write the percentage here, or the decimal value, so that way you guys can see how much that is designated for. And then this second part here, I'm going to look for a value that might be similar to it, and it's like this one here, which is for the 61 to 70. Let me cross out the ones that I've already done, so that way I don't get confused. So 61 to 70 is also 0.9, so about the same piece. Try to make the same size. So that is 61 to 70, 0.09. And then for a piece that is about 4 or 5%, so this little chunk right here is, if these are both 0.9, then there's about a 0.6 left here. So I'm going to use maybe the 4 here to cover that ground. So we'll say that this here is about 41 to 50. And this is about 0.04. So I need that same size here. I'm going to draw it here. So that cancels out this one. And then I'm going to do again for 51 to 60 because it's also 0.4. So a lot of times it's like once I've done one and there's another one in the same size, then I can use that same size to give me an idea of what to draw. So this is from 51 to 60, I believe, and it's also 0.04. Okay, so then the next portion here, maybe I will do this really big one just to get it out of the way. It's about 30%. So in this case, if this is 30%, maybe I'll use this quarter here and then I'll add 5% to it. So if I were to do that, let's say that this is about 5% of that piece. So I'm going to erase this piece here. All right, so this designated piece is going to be for the 91 to 100 is about 30%. Okay, so that means that this piece here is now only 25%, and so is this piece. It's about 25%. So what I'm going to do here is just see what I have left. So I already got rid of this one. So 0.13. I was looking at this one here. 0.13 is a little bit more than 10. So this piece here is about 10, so it's a little bit bigger, like maybe that much if you were doing 0.13. So maybe about that big, and then like this one here is about that big. if it's the same size. Get rid of those dash marks. So what I'm trying to do is make both of these 0.13 because that's what is on my list. So this is going to be from 81 to 90 and 101 to 110. So that allows me to get rid of these. And so all I'm left with is that 71 to 80, which is about a 17%. And there we go, we have our pie charts. Now, obviously, it's not perfect, but it does do a good portion of the sizing here. Like you can obviously see that this size, these two sizes are almost closely alike, and so are these two. This size is bigger than this size. Yeah, so I hope that helps with creating your pie chart. All right, so this would be the end of this video. I was going to put the conclusion on here too, the writing part of the conclusion. However, this video is getting way too long, so I'm going to have to make another video specifically just for the conclusion. So stay tuned for video part 3.